I'm going to tell you how to simplify a parallel force system. Now, parallel force systems means that all of the forces acting on an object are in the same direction or in the that direction, opposite that direction. All right, I have this slab that is laying in the XY plane. Now I'm going to put 3 forces acting on this plate. We're going to find the equivalent force that represents all of these and the resultant couple moment. So we're going to simplify this system down to a single force in a single location. Each of the moments looks like an R cross F. In other words, it's all like a torque, radius times a force. Each of the forces has its own radius to the location where the force acts and the magnitude of the force, the vector. And so each of these is going to look like R crossed with F. And in order to find the resultant, I'm going to sum all of these together. The sum of all of those, and I'll have 3 different terms. The next thing we have to do is equate this R cross F using the force from this step 1 to find the radius, or rather the location, where a single force could be located in order to have the same physical behavior as all 3. So this is what we're looking for. All right, let's find the sum of the forces. Now, if you add 400 newtons in the negative k hat direction to 500 newtons in the negative k hat direction to 100 newtons in the positive k hat direction, what you're going to get is negative 800 newtons in the k hat direction. Now each of these, let's write out 1 for each of the forces. Okay, notice that in this second term, the location of the force is not just in a single direction, it's located by 4 in the x hat and 4 in the y hat direction. So I've got 4i hat plus 4j hat, and those are meters. So this is our resultant moment. And then this is in units of Newton meters. Now the next step, this was step 1 and step 2. The next step is to find the resultant force in one location that will accomplish all of what these forces are doing. The last step is to find the moment, R cross F, and equate that to the moment that we've already got. So this is a cross product. All right, so now I'm going to take a cross product, but let's go ahead and write out the terms. I challenge you to pause the video and see if you can get the same result that I do. Now I'm going to set this equal to the other m, the sum of all of the moments that I got before. Okay, so this must be equal to this. And remember, the 2 unknowns that I'm trying to solve for are the ry and the rx. Now remember that I hats and j hats are different things. They're like apples and oranges. They can't be added together. So we equate these terms and we equate these terms. And if you do, see if you can solve it for yourself and get what I get. And now we could replace this system of three parallel forces with a single force, that force that we got in step 1, at this location, and have the same rotation behavior that we would have from all three of these forces. Okay, and that's it.